About making JavaScript less fragile using some of the type safety enforcing technologies that exist today. I was going to mostly talk about TypeScript, but then I figure you probably want to hear about Flow as well. Before someone points out, yes, it's also how to make JavaScript less agile, because adding type information and everything means that you're going to lose some of the dynamic features of JavaScript in a way. But first, so my background, I'm kind of a startup guy. I've been the founder and CEO at FlowDoc, but I kept coding all the time through that time. When we sold to Rally Software a couple of years, I stayed around for a couple of years and joined Smartly just recently. So Smartly is a Facebook marketing automation company. We're about 55 people at the moment, growing pretty fast. So working with the engineering team there. But now to my agenda. So why would you do something like this? How do you do it? And yes, we're hiring. All right, so if you think back, maybe some of you went to school and whatever, and you were forced to learn Java. And that's probably why you hate many of the type safe or statically typed languages. And there's a good reason for that. I mean, Java was a product of its time, and it's actually improved quite a lot. So Java 8 is totally different from what you learned in 1997. So many of those things are actually not there anymore. And there's a bunch of cool statically typed languages nowadays that actually help you program instead of working against you. One of the cool things that has happened over time is type inference, which is basically just figuring out the type based on the context and based on everything else. So for example, in Scala, you would not have to define the return type for this function, because you can pretty much figure that if you multiply an integer by something, by another integer, it's going to be an integer. So the compiler figures out things like this. And that's kind of one of the big things that's helped a lot in making this more productive. And why would you do it? Well, if you have a larger code base, I know many JavaScript developers mostly write to-do list applications again and again using modern and more modern technologies. But if you happen to have a day job, chances are that you have a code base that's going to follow you for a bit longer time. And refactoring is one thing you have to do to keep it maintainable. But with a very dynamic language, it can be sometimes pretty difficult, because you don't have 100% test coverage with tests actually testing all the cool things. So it would be nice to catch some of the more common errors more easily already at the development time, instead of noticing it when stuff is already in production. And it includes all kinds of like pretty simple things. So this is Visual Studio Code, which has nothing to do with Visual Studio, but it's one of the editors that has a pretty nice support for TypeScript. And as you can see, TypeScript looks a lot like JavaScript. The only difference there is really the specification of the argument type. And again, you don't have to specify the return value type, because it can be figured out simply from the return clause. And the editor will get you all the same things you got when you did Java 10 years ago. So it means if you give wrong types of parameters, or if you misspell any of the key functions, variables, whatever, and so on. So it helps you figure out all kinds of things, which actually nowadays you can figure out many of these things already with ESLint and some of the other static analysis tools. But when you have a larger project across different modules, then it becomes really helpful to actually think of this in the context of the whole app, instead of just like within this module. Cool. There's also a bunch of programming errors caused by the invention of null. As you know, it doesn't have many of your favorite member or properties that you were looking for from there. So actually, some of these tools also help you make sure that you actually handle the case of some function might return a value that is null or undefined. So these types of bugs can be actually catched often with static analysis. Another thing with a bigger project, every time you change something, interface changes, one of the parameters, arguments is a different type, and so on. You want to catch all of these cases, and that's exactly where this becomes useful. So I'm going to have a look at a couple of the technologies that exist today. There's a bunch of others that you could use. They are maybe typically a bit further, or kind of, they're not as close to the standard ES6 JavaScript that you could be writing normally. So in that sense, they might give you a lot of productivity boost, but they are very far away from the original JavaScript. So that's why I'm focusing on these two. And TypeScript is actually, it's just another language that gets compiled to JavaScript, which is kind of problematic because as JavaScript develops, TypeScript needs to develop as well. It's not very easy to combine with your existing transpiling tools necessarily. So that raises up questions with JSX and all the new ES6, ES7, whatever features. But it's actually supported by Google and Microsoft. So they are funding it and they are actively working on it. And for example, Angular 2.0 is largely based on TypeScript. So there's some good tooling support for that as well. Flow is a bit more recent project from Facebook, and it's not really, similarly, it's not really a language that gets converted, or it's not a full language, but rather it's actually a type checker that uses some information from your JavaScript files. And you can even write code using Flow with exact normal JavaScript semantics by just using by commenting out the extra syntax. So it actually even supports that kind of syntax. So you can even use it if you can't break the standard JavaScript syntax for some reason. So yeah, but basically TypeScript is kind of similar to CoffeeScript in a sense that it actually gets compiled and it is a separate language. The cool thing is that they are still following all of the ES6 developments. So pretty much all of the most commonly used ES6 features are already implemented in TypeScript. So arrows, classes, lets, whatever, so they are all actually already implemented. It looks pretty much as you would expect. It is using the new module system as well, so you can export your class or individual functions or anything like that. What you can see is I've added a couple of types for some of the variables. So we actually specify that these parameters are supposed to be of this type. And if I accidentally assigned age to name or vice versa, then I'm going to get a compile time error. So it's going to check on some of those basic things. One of the problems with using any tooling like this is that you're still working in the context of JavaScript. And JavaScript is pretty dynamic, which means that there's always going to be code where you don't know what exactly it returns. And there's a concept of any type here as well. So you can specify that something is of any type and you can get along with it pretty well. So interoperability with your existing JavaScript code has been pretty important here. And they've actually come up with a bunch of pretty clever ways to work with your existing JavaScript code and defining the types of them. So we have generics for kind of similarly to many other languages where you can specify that for this type. So let's say there's a type T that is both the return, that is the type of the argument as well as the type of the return value and things like that. So you can pretty flexibly do that. Also, pretty often you're just looking at the object shape, which is basically just talking about duck typing or saying that this object is supposed to have these properties and that's all I care about it. So there is no absolute like this object is of this type, and there would be some kind of type hierarchy, because that's not always feasible to achieve, but rather it just checks at the compile time as well as it can that it should at least have these properties or these functions. And obviously, JavaScript is so flexible that with the prototypal inheritance and everything, that it needs to be pretty flexible in terms of how you actually define these interfaces. So it can be that there's a thing that has an interface, and it can be used as a function, but it also has the prototype, and it might have other properties there. So it's pretty flexible in terms of what you can do, and you can combine these pretty well as well. So it's very powerful, but writing these can be a lot of work if you have to do it manually for any external libraries. Talking about external libraries, that's one of the major issues with anything like this, because if you were just working on your hello world, that is one file and that's it, and it doesn't have any external dependencies, then you would be good. But as soon as you start using any external libraries, how would the compiler know what does this method in this, or this function in this library actually return? So luckily there's a collection, there's a project called definitelytyped.org that has tooling around this. So there's a GitHub repo with a good number of type definitions for many of the most commonly used libraries, and you can easily create new ones and send pull requests. And then when you just want to use the type definitions for one of the libraries, you simply install it using tsd, that is the command for actually downloading this. And when you do this, if you've set up your build process correctly, so obviously you need some kind of a build process to compile your JavaScript here. So for example, I'm using Gulp in this demo project, and basically it just works. So when I start using the library, I install it here, I install it on npm, and then the IDE is able to give me auto completion and everything else. If you want to look at some of the example projects with TypeScript, it's pretty simple to do for a Node app or something like that. There's a bit more setup to be done if you actually want to do a front-end project with Angular 2 and everything. So, but there's actually a pretty cool kind of starting kit that has everything set up with Webpack and everything. So that's kind of a good starting point. And before you ask, you don't want to do Angular because it's not cool. You want to React and JSX and everything else. Yes, that has to be one of the problems of TypeScript, because it's very difficult to combine one of the JSX compilers with TypeScript, but now it's natively supported. So they are really trying to support all of the major features that people actually want to use, which means that they have a lot of work, but luckily they've been pretty productive so far. And you can see the roadmap from the TypeScript website as well. So, and they are actually supporting many of the ES6 and ES7 features already. Just a quick look at Flow. I've never actually used it myself, but based on my research when looking at this, and sorry, I just copy-pasted this from the Flow website, but it's essentially, in many ways, the syntax is very similar. So in the same way, you kind of specify the types in your code. The way you define the types is a bit different. So if you have external libraries and whatever, it's a bit different, but otherwise it looks very similar. And you basically you can just use this with your existing JavaScript files, and you just add the @flow in the beginning. And again, it's an external type checker that just checks your code instead of compiling it really. And you can actually then just install a Babel task that just removes the type specifications from your code. Yeah, here's something from the type definitions. So one of the challenges with JavaScript is that often you have a function that returns either this or this. So Flow has actually a pretty clever way of specifying that it has to look like this. So if it's an object that has kind leaf, then it's supposed to have a value that is number. Or otherwise, if it's returning an object where kind is breach or branch, then it's supposed to have these other types. So you can pretty interestingly combine the types, and this way support the various scenarios where maybe you have a function call that returns either the results of your call or an error with the error messages or something like that. So you could easily build these types for your own use. I'm not aware of that many projects that use Flow myself, but for example, Facebook obviously tries to use it internally quite a bit. So for example, their GraphQL example implementation is using Flow extensively. So that's a good place to see a bit more advanced project using Flow. Looking at Flow's future plans, there's a bunch of things they're planning to do, and here you can kind of see that many of the pretty essential things are still a bit lacking. So, for example, it doesn't support the definitely typed definition files, which is a big problem because if you actually want to use it with many of the libraries, this is a great way to get started really fast. And then obviously the editor support is something that can be pretty useful. So that's one of the things they're also planning to work on. But Flow is also developing pretty fast, so it might become a pretty cool tool. So yeah, which one is better, you ask? So obviously it depends. Flow can be easy to get started with. It's less obtrusive, so it's in that sense it's good. TypeScript I think it has a future in any case, so it's not going to go away anytime soon. So I think it's a pretty safe bet. But converting an existing project to that might be a little bit of work. If you are going towards Angular 2 or something, then I think the route is probably very clear because in that ecosystem, the tooling is definitely developing towards TypeScript. And then if you're more in the Facebook provided tooling realm, then most likely the Flow is going to develop to a good direction. So I can do just a quick demo of how it actually works. So basically, I have a pretty simple, let me open the editor. Cool. So yeah, I'm using Visual Studio Code here, so it works on all platforms. I didn't normally use it, but just for the sake of showing some of the cool things. I can try Steve Zoo. All right, so yeah, I have a pretty basic Gulp file, so it's just there's a Gulp plugin for compiling TypeScript. It's well, yeah, at least that one seems to work fine, as well as the Webpack one. Then I basically just have a directory of TS files that get built to a build directory with source map and everything. And here you can see that when using this, you can obviously get some of the benefits of the environment actually knowing something about your code. So you get autocomplete, and you know about the parameters of the functions you're calling, and so on. Also, yeah, you get to use the new import syntax. If you try to call this with an invalid parameter type, you get that. What else? So yeah, I mean, that's basically, you get a lot of the compile time help, even across the different modules. So if you're calling, let's say, calling this, and then it actually changes to actually being just a string. Let it be like this. It's going to break other stuff as well. You can see that even with the external libraries, I'm using the async library here, but I installed the type definition, so it knows that if I'm now giving just a string to async.map, then it knows that it doesn't work here either. And in my old code as well, it highlights that, okay, I'm giving the wrong type of parameter to this code. So that's giving you a lot of robustness when you're playing with your code and changing a lot of things, and you get to catch these types of errors pretty quickly. So it's just like coding was 10 years ago before JavaScript came and did something to it. Cool. All right, so that was the end of it. I guess it's time for a quick discussion, questions. And by the way, a plug, yes, we are hiring. Yes, Matthias.
Is it easy to start gradually using TypeScript in your existing project, or do you have to do like convert everything once to TypeScript?
Yeah, you can do a lot with the any type and such, but there's still some setup to be done. So you actually kind of compile everything and have you have both TypeScript files and JavaScript files there and so on. So yeah, there's definitely some work to be done there, but both TypeScript and Flow kind of allow you to do it gradually. Someone else than Sakari? Okay, Sakari, go.
This might be a bit dated because last time I used TypeScript 2-3 years ago, but at that point in some 0 version, quite easily inferred any from pretty much any type. Have you noticed this now?
Yeah, I mean, if you have a look at so for example, the identity function here, it doesn't have any specification. It returns the same thing as you would guess. It just figures out that it takes in any and returns any. So yeah, I haven't that happening in like any actual case where if you actually have a return statement and it's based on some of the variables. But then again, it also depends how you have defined your types with the external libraries, because if all of your external libraries are returning any values, then like that cascades down pretty quickly, and then you end up having mostly any values.
I noticed at some points that well, I was basically coding JavaScript without any types.
Yeah.
Yeah.
Yeah, that could happen, and that's why it's really important to have the type definitions for the libraries and everything else, which can be a challenge if you're converting your project like a module by module, because then you don't have the type definitions necessarily for all of your code. So you start getting more benefits as you progress with that work. Yeah. Someone else, not Lautis? Yes.
So you are showcasing this Visual Studio Code.
Yeah.
Are there any other good tools to use?
Yeah, so I've seen a TypeScript plugin for Sublime, but because I don't use it myself, I didn't actually try it. But someone said that it's okay. I'm not sure if you get all of the same functionality because Microsoft is investing in this quite a bit. Then there's the environment by Facebook. I'm not sure about that one either. What was the name? Lautis knows.
Not live or something like that.
Yeah. So haven't tried that one either, but TypeScript actually lists a bunch of editors that have some kind of support for this. So yeah, there's a good number of these. And actually, I think IntelliJ IDEA actually uses the type definition files even when you're writing JavaScript. I think they are using those to kind of help the auto-completion process somehow. So in that sense, this community is helping others as well. Cool. Yes, no. Oh, Lautis.
So can I add the type information API responses, because that seems to be a pretty large part of the
Yeah, I mean, you can specify an interface for, so if you have a function that queries an API, then you can specify an interface. Actually, you can even specify which fields are optional, which fields are actually required, and so on. And then you can basically define that this like get user or like this API returns these types of values. So I'm not sure if I really answered the question though.
Can I generate a test space for that?
Generate a,
Yeah, I mean, that sounds like a fantastic tool to generate an integration test.
yeah, I mean, I'm not sure if there's some kind of a reflection API here. Probably not. So yeah, I'm not sure about that, but obviously having the type information already gives you kind of the basic test in a sense that at least you're
Sure, but I mean the interface that you just mentioned.
yeah. Yeah, that's a good idea for someone maybe.
All right. Well, I think we can take the rest of the questions offline. So.
All right. Yeah, I'm going to be
Thank you.
around.
Yeah.
So thanks.
Otto.